Okay, so for me, the hero that I'm going to build with you is a ship. And I went and this is the Galaga ship. Anyway, you can pick any ship you want, but I picked the one from Galaga. And this is going to be my hero class that's human controlled. This process should be much more familiar to you because connecting up a keyboard is something we've talked about. So I'm going to go in here and I'm going to just start coding more of this than explaining it, because as I say, I know that is something that we have done. So for me, I'm going to use left, right, up, down for my controls, and I'm going to use spacebar to shoot. Now, let's see. So I've got if. Actually, I am going to give this a little bit more of a planning ahead a bit more. This is something that some of you will want to, I guess, to use again in yours. So I'm going to keep track of a speed here, just like we did before. So at this point, as programmers, you might not recognize that what I've done is actually kind of a bad thing. We'll talk about what would be better afterwards. For now, it's fine if this is the way you program. I mean, this is something I would like you thinking about by May, by June. But right now, does anybody recognize what I've just done with my code here? Have you seen this before anywhere? One of the classes that we've built, does that look familiar? That's exactly what the laser does, right? So whenever you repeat code, it's a good idea to share it instead of retyping it. Because I might find again later on, maybe there's a problem with the laser. I'll have the exact same problem with this hero, right? If I want to control speed, maybe I would build a class to do that for me. So we'll look at improving this one next. But this would be fine right now as beginning programmers, but it's good that you notice whenever you repeat code, there's probably an opportunity to do a better job of reusing the code. Okay, so the key presses I'm looking for is greenfoot.isKeyDown. So if the left key is down, whoops, then I want to move it to the left. And if I want to move it to the left by the amount that I have used for speed, it's going to look like this. Set the location to be where I am minus my speed. And you get to use the same y coordinate. So one thing you might notice already, I'm getting these x's and y's again. I'm going to use them quite a bit in my code. So I'm going to use a variable so I don't have to keep asking Java where my location is. So down here, that just lets me get away with using this and this instead of calling on Java to do it for me. So this moves it to the left. And then we'll move it to the right. So to move right, I'd have to go speed added to it, like that. So when I act, that's all I'm going to say is this is a human-controlled player, so process whatever key. I guess there's more than one key, so maybe a better name would be process keys. Process keys. I can start seeing how this class is behaving. So let's go in here and stick the hero in the game and see if I've at least got some left and rights happening. Looks good so far. So we'll keep working on our code for the hero. Okay. Now, there's a couple things that we need to discuss here. So first, let's do this. A couple considerations, rather, that your understanding of Java will help you understand what's happening. Okay, so we need to draw your attention to one of the features of all graphics in computers, and that's the fact that it's not the same as math, which is kind of weird. You'd think that they would be consistent, but all graphics screens, doesn't matter what we're programming on, this is 0, 0 in the top corner. Right there is 0, 0. This is positive X. But this is actually positive Y when I go down. The good news is it's consistent mathematically. So whenever you're working on the math that you would know about, you know, like trig or other transformations and things on a coordinate graph, it still works out the same. You don't have to think about flipping everything in your mind. You just have to remember that positive Y is going down. So right now, the way I've programmed this is to illustrate that to you. Normally, when you think of up, you would add that speed and it would go higher. But because it's backwards, adding the speed is actually going to push it lower because these are bigger values for y. So when I run it now, I mean, it's too bad you can't see which key I'm pushing. But right now, I'm holding the up. Sorry, I didn't. Maybe I didn't compile this. Just give me 1 second. I'm going to hold the up key. You could try this when you download the code and run it yourself. If you weren't able to keep up with me typing it in. But I'll put my hero in the game. And when I run it, I'm holding the up key right now. Because it's adding y values, it's going down. If I hold the down key, it's taking away the y, makes it go up. Okay? So that's the only quirk that takes a little bit of adjustment from what you learn in math class. So what we'd want to do here is to go up, we'd subtract that speed. And to go down, we would add that speed. Now, I'm going to show you something else that happens here. And what I'm going to do is I'm going to compile it again with the, hopefully working properly. When I put this in the world, this ship, I'm going to hold the up arrow and the right arrow. So before I do that, what do you think you would want to have happen if you hold up and right? What motion do you think you would want to see on the screen if you hold the up and right key? If you're shy, you can make like a point with your hand. Diagonal, that's right, yeah. So I would like it maybe to go diagonal, and when I do that, it's not. It's only going to the right. Well, let me show you what's happening in Java. And again, maybe you prefer that. But what happens is I'm holding the up and the right key. Java says, is the left key down? No. Is the right key down? Yes, it is. And because these are all chained together, no other question is asked. So what I've done is here, by linking them all together, remember when they're linked with an else, only one of those will ever be executed, which is why the up arrow is ignored. So there's a quick fix for it if you want the diagonal behavior. You break the link and start again. So this will allow for the ship to move diagonally if that's what you want your character to do. And the only reason I'm still chaining this is, I guess I could do left and right at the same time, but I'd like only one of those directions to move. Because if I'm holding both keys, they basically cancel each other out. So I'll only use one of them. And if you do so happen to push both buttons, it gives priority to the left key, because the left one is asked first. Okay? So if you hold two buttons and you're not supposed to, my ship will move to the left. If left and right are down, it'll just go left. You don't need to sweat those kind of details now, right? But if you're wondering how do I get that behavior or why is it doing it, it's because of the way we made the if-else's connect. So now I've got lefts and rights. Oops, and just a second here. Up, down, okay. Let me just see. the up and down. Make sure I have the right code here. I'll compile again. Oops. And I'll put my hero in the game. Well, I actually know what's going on now. I was hoping I would get both behaviors visible, but the location is going to be changed. Let's see here. The problem is that because I saved those variables, when I ask this up key, it's reverting back to the original X, not the one I used. So in this case, if I wanted the diagonal behavior, I'm going to have to use what's the live version at this particular instant for X and Y. So this gets it directly from the screen, but it's necessary for me to do this if I want it diagonally, because otherwise it reverts to the originals that I was saving, and that's not the location where I should be. I can provide an alternative solution to you, but let's just verify that now it is in fact doing a diagonal. Fingers crossed. There we go. So I can do diagonals now because it's pulling the live coordinates instead of the original coordinates. So I think that's good enough for us processing keys. The other thing I'd like to do is shoot a laser. So I'm going to make a method called shoot, and I'll show you how that goes. Basically what I want to do is I would like to set this ship so that wherever it's facing, I will stick a laser in the world and then right in front of the ship so that it fires off. So here's what it would look like. I'm going to say laser, I'll call it fire this, and I can set the speed. And if you remember, we had talked about that being too slow. So maybe up here, this ship, I'll keep track of how fast it fires. And I don't know, let's go with lucky number 7. This means it'll move 7 pixels every time. So fire this dot set speed to be that variable. And now that I've created it, I'm going to add it to the world. So I'm going to go and say, please get me the world that you live in. And the hero will go and ask Greenfoot for the background that you live in. And then I'm going to say, add the object, fire this. And now realistically, I'll show you what I'm going to calculate here. And it'd probably be better if I did a quick sketch for you so you can see the math. But if this is my ship, and let's just say that at the moment, this is the way the ship is facing. That means I would like the laser to be put probably right about there. Okay? So let me show you what Greenfoot would do. Greenfoot would say, here's my X and Y. And you know what? To make this a little simpler for us, I think that's what we'll do here is we'll just use that. So I'm just going to stick it. At the moment, it might look a little funny because it's going to fire from the top of the ship. Like it's going to look like the ship got shot by its own laser. And that might be a problem, especially if the laser could inflict damage on the ship. But just to get you thinking about it, that's where I'm going to put it. If it was rotated, you'd have to think about the math to get there. And realizing that I don't want to give you too many things at once in this video, I'm just going to go with the basic laser. But it is possible to figure out the math of this, for example, is half the width of my ship. And this is half the width, I'll call it laser width divided by 2. So I could do some math to work out where those coordinates would go. But we'd also need to know about the rotation, because if the ship now is facing this way, I don't want the laser going out the side. Okay? Anyways, we'll just do the simplest version where we add it to the ship's X and the ship's Y. So there is one easy fix. You're going to see there's some strange behavior here. Let me compile this. Oh, sorry, I need to process a key here. So I'll say if, I think I'm going to use spacebar, greenfoot.is key down. If the spacebar is down, then I will shoot. So once my code compiles, I'll show you what happens. So right now, there's a couple of strange things. First of all, if I put this in, watch what happens. Spacebar. Well, as cool as that laser might have been, it went the wrong way. So a couple of things about Greenfoot that we need to sync up. And again, this is just part of the learning curve when you start. Greenfoot thinks everybody faces to the right. Do you notice that my ship faces up? Greenfoot thinks the ship is facing east, even though the picture is not. So I'm going to go into my folder and do a quick change on my images. So this ship here, I'll open it with this real simple photo viewer. It's one that comes stock with Windows. It's got a rotation thing here. Now it's the exact same way that Greenfoot expects it. So if I recompile, it should use that newest version of my spaceship. And now I can fire my laser. Okay. So yes, you can add your own sound effects to it, but that'll be coming up in your own job. But there's a few things, like we said, we wanted to fix about this. So let's go in here. For example, if I made this ship turn, I'm going to make this ship rotate to 180 degrees, which will flip it the other side. The first problem we have is the lasers still think it's going the default. So how do you fix that? It's real simple when you think about what a laser actually should do. If I'm holding the laser gun, whatever my rotation is the rotation the laser gun should also have. So I'm going to go here and make that update. Fire this, set its rotation to be my rotation. And some of you might prefer to write it this way for readability, meaning this hero, get this hero's rotation and turn the laser to match. Java does that for you when you don't write it, but this is the same thing that Java would be doing. Okay, so I'm going to compile this. And now we can at least see that it should follow the ship properly. So I'll put this in. And I'll set the rotation. So now the ship faces the other way. And when I fire it, that means any laser will also go that direction. Okay? So now the laser is going to follow the ship around. So any comments about my laser right now? What do you think? Is that fair? Oh yeah, you just because you want to be able to win, right? Well, you may decide that there needs to be some reload time in this laser. Maybe you don't want that behavior of firing the gun. So I'll show you a couple of ways that you can make this happen for your ships or your whatever you're adding, and you can figure out which feature you want to implement. The first one we'll look at is how do I make it so that I can't just hold the key down. Okay? So to do that, we have to tell the hero, we have to tell the hero about the space bar. So I'm going to make a private Boolean And Booleans, after George Boole, tell you about true and false, yes and no type of statements. So I'll say key down. This hero will remember if you pushed the key. So what I'm going to do here is say, when the game starts, that space bar is definitely not down. Well, it could be, but we'll say that when you start, the key is not down, it's false. Now when I go to process my keys, I'm going to include this behavior. So the first thing I'm going to check is, I only want to fire if that key is not down. So right now, the key's not down. Okay? So I'm going to say, if the key is down and I was to allow them to shoot, that means I'm allowing them to hold the button and just keep firing relentlessly. So what I'll say instead is, you can only do this if the key is not down. So if the key is not down, you're allowed to check if about firing the space bar. But of course, because I pressed it, I'm going to now tell Java, this key is down. So the next time they try to fire, it's not going to allow it. So this is a problem because right now my spaceship can only fire once, the first time, and then it blocks you from ever doing it again because it saves the fact that the key wasn't down. So here's how I'm going to fix that. I'm going to say, if the space bar is not down, then I know the key wasn't down. So if this did not happen, then that key is not down. And this is managing what's happening to the space bar. There are different ways of doing this logic. This is just one. I'll show you one other possibility we can do here. But there are many ways of doing your logic. But now, when I fire, hopefully, if I hold the space bar, I'm holding, well, you can't see the space key, but I am, in fact, holding it down right now, and only one fires. But the minute I let go of the space bar, Greenfoot knows and says you've let go, so now I can do this. And if you don't like the fact that you can still make that stream, you just go into your image, and you would shrink your laser, and then you'd have a laser beam that's not quite so long and connected like it shows up. Okay, so when you do this, we call this nesting. This is a decision inside a decision, and that logic is fine. You can, of course, use that logic. Another way that you can do this in Java is to use the AND operator. So you might say it in your head is, if the key was not down previously and the space bar is down right now, allow them to shoot. So this is how you connect them in Java. This double ampersand is logical AND. So that's how you make two things happen. If it has to be that the key is not down, but the space bar is down right now, that means you're able to get into this block. You have to have both things true. So AND is one way of linking them. Okay? I'll go back to this when I upload this example for you to see. I'll go back to nesting them, and that way if you want to make more than one condition at one time happen, you can rely on that technique for now. The other thing is to have a timer which only allows the key to fire certain times. So this time I'm going to do a timer implementation. And I'll show you how to do that with the timer. I'll go up here. I'll call this my reload timer. So in here, this is going to represent how many acts go by before you're allowed to shoot again. So basically you shoot and you have to wait. So why don't we try like 10 frames? Maybe I'll make it more pronounced for you. Let's try a 25. So this means 25 acts need to be called before you're allowed to shoot again. So I'll show you how you can make this behavior happen if you want a reload timer in one of your weapons. So down here, we only want to fire if that reload timer has expired. First, you have to wait for that reload timer to get through its countdown. So here's what I'm going to do. Once you shoot, sorry, I've just realized I have that backwards. We'll use this 25, but that's how long I have to wait. I don't want you to wait right at the beginning. But here, what I'll do is I'll set that reload timer to be 25. So now I'm only going to allow you to shoot when that timer hits 0, because that means the timer expired. So if timer, reload timer is equal to 0, then you may shoot the gun, or your laser gun. Just frozen here. There we go. Then you can check if it's time to fire. Okay? Otherwise, what I would like you to do is let the timer go down one. This is the same thing as writing reload timer is what it was before -1. So basically, if the timer is expired, then shoot. But if the timer is positive, meaning I'm making you wait for the reload to have finished, then you can decrement the timer again. And you keep waiting and waiting until you finally hit 0. Okay? So, one safer thing here, by the way, it is logically correct, but you may find a problem with making it just equal to 0. It would be safer probably to make it, you know, if the timer expired, it could be 0 or less than 0, right? More than that time went away, so that's just a little safer. So if I compile it now, this means it doesn't matter if I hold the space bar, you still have to wait patiently for the gun to reload. So you may prefer that behavior to the one I did previously. So I'm holding the space bar, that's why you can see these nice even intervals. Okay, waiting for the reload timer to expire. All right, so the last thing that I'm going to add here is something that people generally like too, is a feature that lets you track where you are with the mouse. Okay, so I'm going to go make a new method. Public void track mouse. Okay. So you might have thought about how do you use your mouse or what would you want to do with it, but I'll just direct you to where you can find the documentation for it, and then we'll have a pretty souped up, a pretty cool hero here. So I'm going to go into the Greenfoot. There's a mouse info that I want, but in Greenfoot itself, there's a method you can ask Greenfoot, please get me the mouse info, which will say what's happening with the mouse right now. And then if you look at what the mouse info class does, I can say, where are you on the screen? What's your X and Y for the mouse? So that's what I'm going to add in here. To track the mouse, I'm going to say mouse info mi is Greenfoot dot get mouse info. Now, it's possible that the mouse isn't on the screen. So in that case, Greenfoot would say there is no mouse. How do you say that an object doesn't exist? Well, it would have to be null. So I'm saying if that mouse info is not null, I can get info about the mouse. And all I'm going to do is say, if that mouse is on the screen, here's what you will do to this actor. Turn towards mouse infos X and mouse infos Y. Okay. So I'm going to run it. And I'll show you what my hero can do. Oh, my hero won't do much without putting that code into the act method. I have this great method here, but I never said process keys and then track the mouse. So basically now I can move and I can rotate my ship based upon where I decide to put the mouse. So let's have a look at how our hero is faring out. So this is what we did before, right? But now when the mouse comes on the screen, see, it's going to track that mouse. So I can now rotate and say, pew, pew, right? And I can control that movement better. I mean, if you're more skilled than I am at video games, which is probably wouldn't take much, but now I have more control over what my ship is doing. Okay, so same can happen for you. That's a pretty souped up hero. The only thing that I'm going to ask about your main character, you don't have to track the mouse. You could do different keyboard movements, but hopefully that gives you some inspirations. The only thing different you're going to have to add to your main character is you're going to have to keep track of what it's acquiring. So for example, every time you shoot something, you should have some kind of counter keeping track so that you can keep it on the scoreboard. So this is only your template for how your human player is going to work, as far as here's a bunch of features, take what you want from it. But the one requirement yours must have is a way of keeping track of score. Okay?